Good morning, everyone. We are here to talk about a new way to Spark. But before we begin, I thought we'll do some exercise. How many of you are new to Spark? Oh, wow. No, we'll make it as much fun as possible for all of us. We are going to be focused on talking about all the things we have done to Spark. I am Susheel. Kaushik, I'm from the product management team. I have my partner in crime, Abhishek Modi, sitting here. He's from the engineering team. And we have Lowe's, one of our customers. We have them talking about all the journey they have had with Spark with us. So let's jump right in. How many of you have not heard the word agent today? OK, all right. I've done my part. So the thing which I want to focus on is from when you're thinking of Spark, agents are going to be there everywhere, no matter where you look. When you're talking about development, we're talking about deployment, where you're talking about troubleshooting and even optimizations, you have to be taking advantage of agents because pretty soon agents will be doing things better than what humans could be doing. So we are focused on making sure that we are fully integrated into the agentic ecosystem, and we'll have some discussion on that topic also. Oops, I went back. So what does it mean to deliver a platform for the agentic era? The first thing that we need to focus on is humans can write 10 queries in an hour. Agents will do 10 queries in a second. So we're talking about scale. Now, scale is not a problem for Spark. For all the Spark developers, we know that. However, cost is a concern. If you run so many queries, and if it costs 1 cent extra, overall, your costs are going to balloon. And what we want to focus on is how do we optimize for cost. And that is effectively what we talk about when we say Spark is built for agents. The second thing is agents without any context is a pure guess. So we want to make sure that we surface all of the insights and the knowledge that we collect to these agents. So Spark is fully integrated into that ecosystem. And finally, if you have an agent, there is no point in having a passive agent. You want to have an active agent which is making decisions also. Now, we want humans to be in the loop all the time. But in some cases, you want to take some automated actions and take the burden off humans also. So that's basically what we are going to be looking at as to how we have made Spark easier, better to use on us. Now, we all know this. I'm preaching to the choir. Spark is the most popular open source framework for doing large-scale data analytics. We all know that. 80% of the Fortune 500 companies are using it. We are talking about people using it for ETL, people using it for streaming. Our customers are doing even interactive analytics on it, and machine learning, of course, is always available in Spark. What we have done at Google Cloud is we have made Spark the best place to run. Now, what do we mean by saying that? What we are saying is we have made it easier to use, we have made it smarter, and we have made it faster. So I'll do a quick poll. How many of you are existing Dataproc customers? OK. So thank you for raising your hand. The thing which I did want to highlight here is that we are changing the name of Dataproc to Google Cloud Managed Service for Apache Spark. I know it's a mouthful. It's a mouthful for me, too. But the key focus is for the new customers who are new to Spark, it's very hard for them to correlate between Dataproc and Spark, and we are making it easier for new users to come in and say, yes, we have a managed service for Apache Spark. So when we talk about making it easier to use, what we mean by that is we have taken the burden of managing Spark and optimizing Spark from your point of view. So that's effectively what we have done. From a smart point of view, we are enabling all the agents to write Spark code and making it easier. So that's basically how we are making it smarter. And from a faster point of view, we have accelerated Spark, and we will have a separate section just on that. And effectively, it's making it easier for you to run your workloads at the lowest price point possible from our perspective. A lot of our customers are using Spark. We are talking about people from the banking space. We are talking about from telco space, even from retailers like Walmart, Flipkart, Lowe's is one of the examples we'll be discussing today. So this is just a small sampling of the customers who are using Spark on us. When we talk about managed service for Apache Spark, we have flexible deployment models at a very high level. You build your applications, and then you have to make a choice whether you want to run it in a clustered environment, which means you're managing your clusters, and then you're configuring your clusters, doing infrastructure management, and from a pricing point of view, you're paying for the uptime, which means for how long the cluster is up and running. So this is very similar to what your on-prem environments would be looking like. But when you're talking about serverless, here you're focused only on your Spark applications. We will manage the infrastructure for you, so we are taking all the complexity away from you. And at the same time, you're only paying for how long the job is running. So depending upon what your deployment model is, you can pick and choose what environment works for the best for you. What we have found is data scientists and some of the advanced customers are moving towards the ease of use. So what they're saying is, I don't want to deal with the headache of managing infrastructure, so they're going the serverless first route. And we have a class of customers who have strong infrastructure management teams, and they want to have the discipline of optimizing for platform usage also. So they are looking for flexibility and control, and these are the folks who are managing the clusters at scale. Now, all of this comes with the same Spark, which means it is fully enterprise grade. It's open and flexible. We support it's fully OSS compatible, and it is AI ready. So it is integrated into all kinds of things that you can do for AI. For example, GPU supports is natively integrated into it. You can create environments with NVIDIA GPUs. We have some friends from NVIDIA in the audience today. You can pick and choose your IDEs. I don't want to bring up the VI versus Emacs wars. I've gone gray because of that. But we support all kinds of IDEs. We are not in the business of saying this is our preferred IDE. So you can pick and choose whatever IDE works for you. And we have integrations with all kinds of environments which allow you to do AI and ML capabilities. Now, this is a slide where I'll walk away from the stage. I want you to take pictures of this slide. The reason for that is this is all of the things that we have launched last year. So if you're an existing user and you're not using some of these capabilities, chances are you're losing out on some of the advanced things that we have done. Now, I'll touch upon some of the key things that we did. The first thing which I'll focus on is if you are a data developer, which means either you're a data scientist or a data engineer, what we have done is we have enabled many different IDEs for you. The first one being you can create a notebook in BigQuery Studio, and you can start using a notebook right away. It connects to serverless environment, and you can get up and running with very little headache. The second one is Workbench. We have a Workbench capability that's available, so you can do, it's fully integrated into the AI ML workflows. And we have a concept of bringing your own Jupyter or VS Code. So you can have these IDs deployed on your laptops and connecting to a Dataproc environment. So all of these three things are available. Now, if you're a data scientist, we have made AI ML easy by making it easier for you to spin up an environment with GPUs on it. All the libraries, AI ML libraries are pre-packaged for you, so you don't have to worry about dependencies and deployment management. And all the AI, most popular AI frameworks are also available, starting with XGBoost, PyTorch, TensorFlow, and many more. If you are building the next generation lakehouses, we have fully integrated into the lakehouse ecosystem. We are integrated with our lakehouse capabilities that we just recently announced. We are fully supportive of Iceberg, Delta, Hoodie formats, Unity catalogs. And also at the same time, Spark can work on data which is stored in BigQuery native format also. So from Spark environments, you should be able to see all the data that's available to you. Our goal is you should be able to store the data in the format that you want and analyze it using the processing engine you want with all the security constructs that are applied uniformly across all the processing engines. And that is effectively what we have enabled in the lakehouse. And last but not the least, from a cost efficiency point of view, we have enabled many features. The first one, which I did want to highlight, and we've been talking about it for a very long time, is flexible VMs. If you're running into obtainability challenges for the specific VM shape that you're looking for or the VM family you're looking for, we have enabled flexible VMs, which means you can pick and choose many different VM families to pick from. And whichever is the VM that's best available at that point in time, we will be picking that for your workloads. So making your workloads get access to the environments as quickly and as efficiently as possible. We have improved support for spot VMs, and at the same time, we have auto-scaling enabled. As I look at our customer data, we are realizing not many customers are using auto-scaling. So if you're using auto-scaling, you can actually optimize your cost better. So these are some of the things that we did in last year. So what are we announcing at Next? So one of the things which I'm not sure if you got a chance to see this presentation, is we announced Google Cloud Data Agent Kit. What does this mean? We are reimagining exactly how you do work on Spark on us. So imagine you start your work in a VS Code-based IDE, and you just be there. You don't have to move out of it. Whether you're doing development, whether you're doing, taking advantage of GenAI capabilities to generate code, whether you're troubleshooting, monitoring that job, or even on a regular basis scheduling that job and monitoring how that job is running over time. All of that activity can be done just from the VS Code without going into some other environment to monitor and manage the applications. So that is effectively what we launched. There are a lot of demos available. We can have a deeper conversation if required, but the key message which I want you to take away is, if you have a VS Code-based IDE, whatever it is, you should be able to take advantage of it. If you have some of your, if you have some of your agentic ecosystem enabled, Gemini or Claude or whatever else, which will assist you in code generation or even agent development, it's fully integrated into this IDE. And at the same time, even you can use, if you're a power user, which I am, I like command line over UI any day. So you can use command lines also in order to get recommendations as well as agentic work done. Like I was mentioning earlier, we are fully integrated into the lakehouse. We have a high-performance, managed high-performance Iceberg capabilities that we have enabled. You can do unified governance, which means you define your security policy once, and no matter which processing engine you're using, you will be able to analyze that. And we have also enabled cross-cloud capabilities, which means for data which is registered on GCP, you can be accessing data which is sitting in S3 catalogs also. And finally, we are announcing GA of Lightning Engine. It is our next generation performance optimizations for Apache Spark. Now, how you will measure the performance improvements, I'll focus on two things. One is 4.9. This is basically, if you were to take pure open source and deploy it, will be 4.9 times faster than that. And the second thing which I did want to touch upon is the 2x here. If you are comparing us to the leading price performance engine in the market, we'll be half the cost. So how are we going, what did we do to Lightning Engine and all the things that we did under the covers? I don't want to go into the details here. I'm going to invite Abhishek Modi. He's from the engineering team. He'll go deep into all the things that we have done to Spark to make it run faster on us. Thank you.
Yeah, thank you, Susheel. Hello, everyone. So I am super excited to launch the GA of Lightning Engine. And as Susheel talked about how our customers are observing significant performance improvements using Lightning Engine. And I am going to deep dive into the technical architecture on how we achieved 4.9x performance improvement with Lightning Engine. So first of all, Lightning Engine is completely compatible with open source Spark APIs. Whether you are using dataset APIs, data frame APIs, SQL APIs, Spark ML APIs, streaming APIs, or GraphXL APIs. Your workload will just run on Lightning Engine. It is a single-click migration to Lightning Engine. Now, beneath the APIs, we have built the state-of-the-art Lightning Engine optimizer. So this optimizer is inspired from F1 and Spanner Query Optimizer, which are proprietary Google engines. This optimizer makes sure that we generate super optimized plan for your queries. And once we have query plans generated, which is optimized for the performance, we have intelligent pushdown layer. This layer decides which operators can be executed on the native engine and which operators still need to be executed on the Java engine. Now, this intelligent pushdown layer, apart from generating the physical plan, also takes care of defining the optimal configurations for your job. And this layer also makes sure that we have a unified memory manager on top of our execution engine. Now, once the plan has been generated, we have built our own native engine, which is inspired by the Velox, but with lots of proprietary enhancements from the Google site. This native engine is completely SIMDized, written in C++, and leverages the CPU architecture very efficiently. And then, based on our customer workload experience, we decided to optimize the scan performance significantly. And for that, we built native GCS connector and native BigQuery connector. These are the two major data sources that are being used by customers on GCP. So let's start from the GCS connector. 90% of our customers are scanning data from the GCS or writing data to the GCS. GCS is the lakehouse for GCP customers because all of the data is present on the GCS. To provide the best performance on the GCS, we have done 4 major techniques in collaboration with the GCS team. So first, prefetching. Why should compute wait on scan? We can always have background threads that can prefetch the data that needs to be processed. And that's where prefetching helps a lot. So we have created a background thread pool that will prefetch the data that is about to be processed by the Spark engine. Second, lazy materialization. So our native engine is a columnar execution engine. And for columnar execution engine, you can always say that these columns are not immediately required for the execution, because some columns would be required immediately, but some columns you can do materialize lazily. So we have introduced a concept of lazy vectors, which allows you to lazily download the data from the GCS, and your compute is not bottlenecked on that. Third, caching. As you all know, Parquet has Parquet footer, Iceberg has their metadata files, Delta has their Delta logs, and each of these things contains the metadata about the table or metadata about the file. All these things are being fetched again and again from the GCS, and impacts the performance as well as impacts the cost because you are making so many GCS API calls. We decided to cache all these things in the memory so that we reduce not only the performance, but we also reduce your GCS costs. And the last is the metadata optimizations. So we worked with the GCS team to significantly reduce the number of metadata operations. And I'll go deep into this optimization. As you all know, metadata is more expensive, in fact, significantly more expensive than the read API operations on GCS. If you run a single Spark job today with millions of files, we will end up doing 2 million to 3 million metadata operations in open source Spark. And this incurs not only the cost of the GCS, but it also slows down your job because each task is doing a couple of metadata operations before it starts processing. So to optimize it, we worked with the GCS team and started using lexicographic listing APIs to get all the metadata of the files that needs to be processed. With this new listing API, we can get all the metadata of those files in hundreds of calls in the driver. And then we built a new protocol between driver and executors to pass on this information to the executors, which are processing that file. So instead of calling this metadata operation every time for each file in each executor, we are just calling it in driver using the optimized lexicographic listing APIs. And here is the impact. So this is the store sales table that is being scanned. And you can see number of APIs are just half. So this is not only reducing the performance or optimizing the performance, but if you look at your GCS cost, you'll see just 2x reduced cost with the Lightning engine. Moving forward, another thing that we optimized in collaboration with the GCS team is developing a direct path and a BiDi API to read from the GCS. Now with Parquet files, columns are stored at different offsets. And that means you have to open the file and then keep on doing seeking. So you are kind of opening the file and hopping to different offsets. And this hopping was a very costly operation because GCS fundamental APIs didn't provide a way for you to do the seeks. So what we were doing previously was opening files multiple times. And again, that slows you down, and that impacts the performance as well as increases the GCS cost. So we moved on to a new API that we call as bidirectional API. through which you can do the seeks in the GCS. So you open it once, and then you can seek to multiple offsets and read from it. And along with that, we also added support for vectored read. And what does it mean? It means that we can do parallel reads from the same file. So instead of doing all the reads sequentially, now we do all of them in parallel. And when we observed it with our customer workloads, they were observing up to 30% improvement just with this optimization. Moving on to the other data source, that is BigQuery. So as Susheel called out, Lightning Engine also supports reading from BigQuery native tables. And we have done significant optimizations on how we fetch data from BigQuery native tables. In vanilla Spark, the data is fetched from BigQuery native tables in arrow format, and then we convert it into unsafe row. So there is a huge conversion cost that we are paying. In Lightning Engine, we added support to directly process data in arrow in memory format. So you avoid this duplicate conversion cost, and you get a up to 30% improved performance with Lightning Engine when your data source is BigQuery native tables. Moving on to the execution engine, one of the key goals for us is single-click deployment of Lightning Engine. So customers shouldn't require to tweak their jobs to move their workloads to Lightning Engine. We have solved it by making sure that Lightning Engine is 100% compatible with open source APIs. But the other main gap was, how do we solve on-heap versus off-heap memory? Because Lightning Engine requires off-heap memory, while JVM-based engine requires on-heap memory. So we built a unified memory manager on top of Lightning Engine that can fluidly transfer your memory from on-heap to off-heap and off-heap to on-heap as required. And with this optimization, we were able to support Java UDFs because Java UDFs requires on-heap memory. So native engine can use off-heap when it is executing the operators in native, but it can transfer the memory to the Java when Java UDF is being executed. Another quick optimization that I wanted to talk about is broadcast hash joins. So 40% of our workloads have broadcast hash joins. It is a very common technique in Spark to improve the performance. In Spark, if you look at broadcast hash joins, we are building hash tables in each task. This not only degrades the performance, but it also impacts the memory layout, because each task is having a copy of hash table. So to improve the performance as well as reduce the memory footprint, we have implemented a new technique to cache the hash table in executor. So instead of rebuilding that hash table again and again, we cache it once in executor and then use it across the tasks. Again, this improves 30% performance workloads, which are bottlenecked on broadcast hash joins. So quickly talking about the optimizer. So as I called out earlier, we have developed state-of-the-art query optimizer, which is cost-based and inspired from F1 and Spanner. Statistics is the heart of the optimizer. So we have developed multiple sources of the statistics. First, we fetch statistics from the file listing. Second, we fetch statistics from your historical runs. So most of the customers are doing recurring runs, and we collect the statistics that can be used for further optimizations. Third, we collect statistics from Iceberg and Delta manifest files. Fourth, we have developed techniques to collect additional statistics from the runtime. So we collect statistics in the shuffle phases. And fifth, we use columnar metadata, which is called CMeta, to collect advanced statistics. With all these statistics, we were able to develop 30+ advanced optimizer rules. A glimpse of it is here, but I don't want to call out everything. And we will try to deep dive into it for some of those. So lots of our customers have very simple query pattern. They do multiple joins, and then they try to aggregate on top of those joins. So this is a very common query pattern that our customers use. If you look at this query execution plan, you will see multiple shuffle stages. And shuffle is one of the most expensive operator in Spark. It impacts the performance very badly. We developed an optimization technique which leverages the statistics and tries to push down partial aggregation below the shuffle. What does it do? So it reduces this shuffle drastically because you are trying to do aggregation before this shuffle. In real-world customer workloads, we have seen this technique to reduce the shuffle by up to 10x and improve the query performance by 2x. So your workload just runs twice the faster when this optimization is triggered. So how many of you folks have struggled with optimizing or tuning the Spark configuration? I think each one of us has spent hours doing that. And one of the significant pain point that I've heard in all our customer conversations is shuffle partitions. How do we figure out a sweet spot for shuffle partitions? There are two major problems with shuffle partitions. One, it is at a query level and not a stage level. And shuffle happens at the stage level, not at the query level. Second, if you set it too high, your query becomes slower. If you set it too low, your query goes out of memory. And it is very difficult to tune it because your data set keeps on changing, your nature of the workload keeps on changing. So we developed a new algorithm that does it based on the historical stats and the runtime stats and decides the shuffle partitions per stage. We made sure that we don't break reuse exchange and reuse subqueries as part of this optimization. At the end, Lightning Engine provides the fast, intelligent, and integrated Spark experience for all our customers. To learn more, please join our group discussion at 9:30, where we can go into more technical depth. And now, I'll hand it over to Saurabh, who will share Lowe's journey to adopting Lightning Engine. Thank you.
Thank you, Abhishek, and good morning, everyone. So far, we have seen what is possible with Spark and Lightning Engine. Now I'll more focus on, and I'll share one of our experience, what you see when you run a Spark serverless at a scale like Lowe's. So my name is Saurabh, and I'm a senior director of data engineering at Lowe's. We build a platform that supports AI analytics, and we power all of our AI strategy with our data lake. Let me move to next slide. Sorry, this was the slide. So here is a quick context about my talk. We'll talk about Lowe's, and I'll touch base the pain point which we were facing and most of the enterprise face when they transform their journey. And we will see what differently we did to overcome those challenges and how we have solved those problems. Most importantly, I'll talk about what business value it unlocks, and then I'll close my session with some of the key learning which we have seen, followed by the keynotes. So Lowe's is Fortune 50 company, world's second largest home improvement retailer, and soon we are going to be first. So we have our headquarters in Mooresville, North Carolina. We have 100 years of experience to serve our customer in a better way. We have 1,700 plus stores across US, and we have approximately 16 million customer transactions every week. Last year, our revenue was 86 billion. Now, before I deep dive to this slide, let me just tell you some of the glimpse from our experience. 2 years back, we were very heavy on on-prem. We were more complex. We were having more complex system on-prem. We have transformed them to GCP. We have started our migration journey 2 years back, and few months back, we have completed as well. In the complex system on-prem, we were not having clear segregation of the custodianship, the data mapping, and all. So right now, we operate with 50 plus of the cross data domains, thousands of pipeline, petabyte scale of data. We have batch pipeline, streaming pipeline, AI workload running together. So here is the thing. At some point, scale is not a challenge, or scale stop being impressive and start becoming a painful. That is how we realize we needed a solution that helps, or we realize whether our data lake, is it smart enough, faster enough, and is it simple enough to solve challenges on time and at scale? Then, some of these are the challenges I think Abhishek and Susheel has talked about. Some of these challenges includes operational overhead. One of them is cluster provisioning. Because from the on-prem to managed cluster in GCP, that was the biggest challenge. How will you provision, how much time it will take, and what are the configurations you have to manage? So using serverless Spark, we overcome those challenges. And the other part was capacity planning, tuning our jobs, and then the lifecycle management. Then, this is how we have solved some of our storage problem. What we did, that many enterprises missed to do, we consolidated, we mapped our data domains to principle of, or I would say we have mapped our data domain to pillar of the retail architecture, tech architecture, buy, move, and sell. We have consolidated customer data, marketing data, vendor data, purchase order data into a unified data lake that help us to improve operational overhead. It reduces frictions between teams, and definitely it helps us to have a better customer experience. So we made a bold move. We were facing not only processing problem, we were facing managing overhead as well, and we were having all those difficulties. So we made a bold move to choose or to integrate serverless Spark in our data ecosystem. Not only it helps us to overcome the maintenance and management challenge, it helps us to optimize our cost and optimize our jobs, which can meet business SLA. Lightning Engine optimize the execution as well as reduce the cost. It is smart enough, intelligent enough, and then it is lightning fast. So here is the architecture. I'll just brief you about this. So what we did when we decided to migrate it to GCP 2 years back, we have not done lift and shift, which is the different part which we did most of the time. We have mapped our GCS to medallion architecture. I mean, we followed the medallion architecture. We followed raw and bronze layer to our GCS. We mapped that. And then we did BigQuery for our silver layer. On top of that, with the help of Lightning Engine and BigQuery optimized query engine, we have built our gold layer. Once we have set up the foundation of our bronze, silver, and gold, the important part is we have enabled end-to-end lineage and the catalog, also the certification in our data governance layer too. That serves or that build most of our data and AI build product. So here is the thing. Let's talk about the hero of this story. That is our Lightning Engine. Lightning Engine is columnar-based processing. It supports columnar-based processing. It optimizes your query. It optimizes your job. It builds an execution plan like Susheel and Abhishek was talking. And all these features or offering what Lightning Engine do, it gives us the faster outcome. It helps us to run job faster at definitely lower cost. And we have seen, like they were mentioning, we have seen the difference from the previous job to this job. It helps us almost 10% of the total cost. Then, so far we have seen the storage and the processing problem. But as we all know, all these things matters when you have your data with a good quality. It doesn't matter if you do not have your data trusted. So we have built our data governance layer on top of our data lake that validate, audit, and certifies our data metrics. And that gives us the confidence to have a trust from business and to deliver our data product and AI product on time. Now, all these things are good, but when we realize that how it is helping to the business, then these are the few glimpses of that. Business feels that it is not only reducing operational overhead, it is innovating on a faster pace. We also adopted AI at scale. It is helping us to improve our customer experience. And then now Spark is no longer just a compute for us. It is a strategic business accelerator. So there are few key takeaways, and one of them is definitely we have moved from managing infrastructure. We had a lot of thousands of servers in our ecosystem. We have completed those migration on time, and then we have moved out of that. We have moved to NoOps infrastructure. The second key takeaway, Lightning Engine help us to boost our performance at scale to meet our business SLA on time. The third key takeaway, with the help of Spark and the GCP ecosystem, we are able to integrate our data governance layer, which help us to build our certified metrics and which help us to build our scorecard and AI-based products. It helped to adopt AI and cross-data domain and data sharing at pace. So far, we have completed half of our journey, and this is the second phase of our, which is going to be soon, and we started working on it. We are exploring open file format or open lakehouse format, such as Iceberg. Abhishek has touched on this, and Lightning Engine is helping us this. We are planning to use, or we started already, not to the scale. We are using Gemini to optimize our workload. And we have done most of the MVP and POCs with the Lightning Engine. We have seen the good performance and the improvements. We are planning to expand our Lightning Engine adoption to accelerate our large-scale workload. With this, I'll give a pause. I'll call Susheel to the stage, and then he will brief you to that. Thank you. Thank you so much, audience.
Thank you. All right, so just to recap, Google Cloud is the best place to run Apache Spark. Why do we claim that? First, we have made it easier to use. Starting with the development experience, we looked at how you can bring in your VS Code and use our agentic kit and start developing easier. We talked about integrating with Gemini and enabling you to do all kinds of agent development also on it. Easier to use from a perspective of fully integrated with lakehouse, which means we have support for all kinds of open source lakehouse formats available to you. Smarter, you can use Gemini to develop faster. You can troubleshoot using Gemini, and you can even monitor things straight from the single interface. Abhishek Modi talked a lot about what we have done to Lightning Engine and all the internals under the hood. The goal being we want to run Spark as fast as possible, as efficiently as possible, as easily as possible. And effectively what we are talking about is we are the best place to run Spark. And by the way, the product name that we want to be looking for going forward is Google Cloud Managed Service for Apache Spark. So with that, I would say thank you for your attention.